in the previous class already we were in the up to matrix product, and there also we have found the product of the matrices does not follow the commutative law. So whatever the operations already we have done, the first one is called the matrix addition. Now according to the property, the matrix addition follow the commutative law. Already we have seen. Okay. Second one, matrix addition also follow the associativity. Okay. Now the third one property for the scalar multiplication. Now the scalar multiplication also follow scalar multiplication with matrix follow the distributive property or distributive law. Now what is the distributive property? Suppose we have three numbers. A is a number into B another number plus C. So when we are multiplying it, we may say like that. At first we are not adding it. So we may write A into B plus A into C. So that means what is happening? A is distributing among B and C. A is distributing among B and C. So that's why that distribution is occurring. We are calling it as the distributive law. That means the A is distributing with B and C. That is also happening with the scalar multiplication. That is the case of the normal number system. Suppose we have two matrices A and B, the two matrices. Then we have a scalar, that is the small k. So we can say k into A plus B. So that k scalar can be distributed over k into A and k into B. Suppose we have a number, let k is equal to 5, A is equal to 1, 2, 3, 4, that matrix, and B is suppose 3, 4, 5, 6, like that. Okay. So the left hand means 5 into 1, 2, 3, 4 plus 3, 4, 5, 6. At first we are just adding this. So that is 4, 6, 8, 10. So that is our A plus B. Okay. So whatever the result we are getting, now that one 20, 30, 40 and 50, like that. Okay. So that is our left hand side, K into A plus B. Let's check what happens with the right hand. So 5 into, at first 1, 2, 3, 4, that is our K into A, plus then 5 into 3, 4, 5, 6. Just multiply, that is K into B. Multiply at first, that is we are getting 5, 10, 15, 20, plus 15, 20, 25, 30. So after the addition, we are getting that is 20, 30, 40, 50. So what is happening? The left hand is originally was our K into A plus B, and right hand side is equal to K into A plus K into B. That means the scalar multiplication follows the distributive law. Is that right? Okay.
Yes,
Yes,
sir.
sir.
Yes,
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 sir.
sir.
Yes, sir.
Yes, sir.
Next one property already we have, that is the existence of the negative identity. That means addition law or addition law with the null matrix. Already we have found that one, null matrix. That means
Hello, sir.
if A is a matrix plus the null matrix O, that one we are getting O, and then O plus A. হ্যাঁ বলো।
স্যার একটুখানি স্ক্রল আপ করবে স্যার, আমি ওটা লিখছিলেন
Which one?
স্যার, এই যেটা স্যার স্কেলার রাইট হ্যান্ড সাইডটা স্যার লিখছিলাম আমি। হ্যাঁ স্যার, একটুখানি একটা মিনিট দাঁড়ান স্যার, আমি এখন লিখি।
স্ক্রিনশটটা তুলে নে।
Already I send the PDF.
ওকে স্যার, ওকে স্যার,
Already I am sending each and every time the PDF, na?
ওকে ওকে স্যার।
You may also check there. Okay. Okay, there will be no problem. Okay. Next one. So that is the law with the null matrix. Another one is the existence of the additive identity. That means if we have A plus minus A, we are getting the null matrix. Another one property, that means also that one is true. Minus A plus A is equal to the null matrix same. Okay. Another one property that is called the important way, that is commutative law for matrix product. For matrix product, but we know the matrix multiplication or the product of matrices does not follow the commutative law. That means A cross B is not always B cross A. So matrix product or matrix multiplication does not follow commutative law. Already you have seen this. There are two other properties. Then the associative law for the matrix product. Okay, suppose we have three matrices, A, another one B, another one C. What is the associative law? Once again, according to the normal number system, we can say if that is the case of multiplication, A cross B cross C, that is also equal to, if we at first multiply B and C, then the A. So A cross B cross C, that is also equal to A cross B cross C. Now here we are proceeding with the three matrices. Let's check the associative law holds or not. Suppose the very first one, A, is equal to 1, 2, 3, 4. For B, suppose that one 1, 1, 1, 1. For third C, that is suppose 2, 1, 1, 2. Okay, no problem. So first of all, the left hand side. Left hand side means A cross B cross C. So here first one 1, 2, 3, 4 cross 1, 1, 1, 1. Then the 1, 2, 2, 1. Okay, that means A, B, C. Let's at first multiply the A cross B. 1 and 2 with 1, 1. First row, first column. So that means 1 cross 1 plus 2 cross 1. 1 cross 1 plus 2 cross 1. 3 cross 1 plus 4 cross 1. And 3 cross 1 plus 4 cross 1. That is the multiplication of AB. Into then 1, 2, 2, 1. That means the C. What is the result here? 1 plus 2, that is 3. 1 plus 2, that is 3. 3 plus 4, 7. 3 plus 4, 7. So that is our AB into 1, 2, 2, 1. That means C. Let's check. Now 3, 3, 1, 2. That means 3 cross 1 plus 3 cross 2. 3 cross 2 plus 3 cross 1. 7 cross 1 plus 7 cross 2. 7 cross 2 plus 7 cross 1. What is the result here? We are getting that is 6 plus 3, 9. That one is 9. That one is 21. That one is 21. So that is the result of A cross B at first, then C. Let's check what happens if we multiply the B and C at first, then A. Okay. So A cross B cross C. That means 1, 2, 3, 4 cross 1, 1, 1, 1 cross 1, 2, 2, 1. Okay. That is B, that is C, that is A. So first multiplication 1, 2, 3, 4 cross 1, 1, 1, 2. That means 1 cross 1 plus 1 cross 2, 1 cross 2 plus 1 cross 1, 1 cross 1 plus 1 cross 2, 1 cross 2 plus 1 cross 1. So we are getting 1, 2, 3, 4 cross 3, 3, 3, and 3. Okay. Then the multiplication. That one is A, that one is BC. So that means 1 cross 3 plus 2 cross 3, 1 cross 3 plus 2 cross 3, 3 cross 3 plus 4 cross 3, and 3 cross 3 plus 4 cross 3. So we are getting the result, that is 9, 9, 21, and 21. Okay. So that one is also equal to A cross B cross C. So the associativity law holds for the matrix product. That means A cross B at first, then C. That is also equal to A cross at first, B cross C. So associativity holds. Okay, that is right.
Yes,
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 sir.
sir.
Yes, sir.
Another one property that is called the distributive. Distributive law for matrix product and addition. That means the same thing here, the distribution is occurring. Suppose we have a matrix A into B plus C. That is the three matrices. The first operation is addition, then the product of the matrix A. So that means that matrix A is distributed over B and C. The same three matrices we are going with. A is equal to 1, 2, 3, 4. B is equal to 1, 1, 1, 1. C is equal to 1, 2, 2, 1. Suppose. Okay. So the left hand side, A cross B plus C. A cross B plus C. So that one, 1, 2, 3, 4 cross 1, 1, 1, 1 plus 1, 2, 2, 1. Then 1, 2, 3, 4 cross. After addition, we are getting 2, 3, 3, 2. Then the multiplication, we are getting 1 cross 2 plus 2 cross 3, 1 cross 3 plus 2 cross 2, 3 cross 2 plus 4 cross 3, 3 cross 3 plus 4 cross 2. Okay. Then we are getting the result as 2 plus 6, that is 9, 3 plus 4, that is 7, 6 plus 12, that is 18.
The first one, that will be 8 in case of 9.
First it 8 হবে।
Right, that one is 8, na? Yeah, that one is 8. And that one 9 plus 8, that means 17. Okay, is that right?
Yes, sir.
Yes, sir.
Something is looking wrong. Okay, let's check with the second one, right hand side. That would be better. A cross B plus A cross C. So A is equal to 1, 2, 3, 4 into 1, 1, 1, 1 plus 1, 2, 3, 4 cross C is equal to 1, 2, 2, 1. So then multiply it at first. 1 cross 1 plus 2 cross 1, 1 cross 1 plus 2 cross 1, 3 cross 1 plus 4 cross 1, and 3 cross 1 plus 4 cross 1 plus 1 cross 1 plus 2 cross 2, 1 cross 2 plus 2 cross 1, 3 cross 1 plus 4 cross 2, and 3 cross 2 plus 4 cross 1. So the result is here 3, 3, 7, 7 plus 3, 4, 3 plus 8, 11, and 6 plus 4, that is 10. Okay, so we are getting the result. Sorry, that one must be
Sir, again, that will be 5.
4 into 1, 5. 4 plus 1, 5. Okay, so that one is 8, that one is 7, that one is 18, that one is 17. So already that one means that one. So also the distributive property holds. It means A cross B plus C is equal to A cross B plus A cross C. Yet now that is okay.
Yes.
Yes.
Yes, sir. Yes, sir.
Okay.
Yes.
So next we
Yes,
should
sir.
proceed. We should proceed with another term. That one is called the transpose of the matrix. Okay. Transpose. Transpose of the matrix. That means we are interchanging the elements of row and column. Okay, suppose we have a matrix A with the order 1, 2, 3, 4, 5, 6. That means how many number of row are there? 2. How many column? Na, 3. Just what we are doing here, interchanging the row and column elements. That means the transpose is written in that way. The transpose of the matrix A to the power capital T, like that, that is the index. Just interchange the row and column, whichever is in our first row, that is 1, 2, 3. Write down that one as the first column. Okay, next one, which one is our second row? Write down that one as our second column. So that means that one was 4, 5, 6. We are writing it as 4, 5, 6 as the second column. So what is happening? That is the 3 row and 2 columns. So that means interchange the row and column. Same as our first one column was 1, 4. Now that is our first column. Sorry, first row. Which one was our second column? That is 2, 5. That one is our now second row. Same as which one was our third column, 3, 6. That is now our third row. Just interchanging the row and column, so the order must be changed for the transpose. Clear?
Yes,
Yes,
sir.
Yes, sir.
sir.
Next, some properties for the transpose of the matrix. First one, suppose we have a matrix A. We are transposing it. Then once again, we are transposing the transpose of the matrix. We are getting the matrix A itself. That means that is looking like we have a D, we have a reflection, we have a transpose. We are getting that one. After that, once again, we are transposing or we are reflecting. So we are getting the same one. That is also the same. Suppose A is equal to 1, 2, 3, 4, 5, 6. So that is our 2 cross 3. So A transpose means 1, 3, 2, 4, 5, 6. And once again, we are transposing it. A transpose of transpose. So if we transpose it, we are getting 1, 2, 5, 3, 4, 6. That means the matrix A itself. That is called the transpose of transpose. Okay. Second one property. Property number 2 for the transpose. A plus B transpose is equal to A transpose plus B transpose. Suppose we have 1, 2, 3, 4, and that one 7, 8, 13, 17. Okay, so we are at first on the left hand side. That means A plus B whole transpose. So A plus B whole transpose, just add 1 plus 7, 8, 2 plus 8, 10, 3 plus 13, 16, 4 plus 17, 21. Then it's transpose. So we are getting 8, 10, 16, and 21. So that is the left hand. Then A transpose plus B transpose. So A transpose is equal to 1, 3, 2, 4 plus the B transpose. That means 7, 8, 13, 17. So after addition, we are getting 7 plus 1, that means 8, 3 plus 13, that one is 16, 2 plus 8, that one is 10, and 4 plus 17, that is 21. So both are same. So that means A plus B whole transpose is equal to A transpose plus B transpose. As like the second one property, the third one is for the subtraction. That means A minus B whole transpose is equal to A transpose minus B transpose. If we have the same, suppose 1, 2, 3, 4, and B as 13, 17, 31, 22. Okay, so A minus B whole transpose, after subtraction we are getting minus 12, minus 15, minus 28, and that one minus 18. Its transpose, that means minus 12, minus 15, minus 28, minus 18. Same as A transpose minus B transpose. So A transpose means 1, 3, 2, 4 minus 13, 17, 31, 22. And we are getting the same result, minus 12, minus 28, minus 15, and minus 18. So both are same. That means A minus B whole transpose is equal to the A transpose minus B transpose. Next one is with the scalar. Scalar number means if we have a scalar small k, then A is the matrix and then its transpose. We are getting the result same as k into A transpose. Let's check with a very small number 1, 2, 3, 4 and k is equal to the 5. So the left hand k into A whole transpose. That means 5 into 1, 2, 3, 4 whole transpose. At first multiply. In the case of scalar multiplication, each and every element of the matrix would be multiplied with the scalar. So here we are getting 5, 10, 15, 20. Its transpose, that means we are getting 5, 10, 15, 20. That is left hand. Now the right hand. K into A, its transpose at first. So 5 into 1, 2, 3, 4, its transpose. That means 5 into 1, 3, 2, 4. That means 5, 15, 10, and 20. So we may say that one is equal to that one. So up to that, the 4 properties of the transpose. The first one, A transpose of transpose is equal to the A. That is the addition case, that is the subtraction case. The fourth one is the multiplication with the scalar case. Fifth one is the most important. Always remember. 5. And if we have A cross B, that means the product of the matrices, then its transpose is equal to B transpose cross A transpose, not A transpose cross B transpose. Always B transpose cross A transpose. And that's a important thing. Let's check. Suppose we have a matrix A. Okay, that one 1, minus 1, 2, 2, 1, 0. That means 2 cross 3. B is equal to 1, 3, 2, 0, minus 1, 1. That one 3 cross 2. Now at first we have to check A cross B is possible or not. Okay, it's column number 3, it's column row number 3. So matrix multiplication is possible, then we should proceed to the transpose. So at first we are doing the multiplication. What should be the resultant matrix? That must be 2 cross 2 because that 2 cross 2. Okay, so here 1 into 1 plus minus 1 into 2 plus 2 into minus 1. 1 into 3 plus minus 1 into 0 plus 2 into 1. Then 2 cross 1 plus 1 cross 2 plus 0 into minus 1 and 2 into 3 plus 1 into 0 plus 0 into 1. Okay, and after that we should proceed with the transpose. So whatever we are getting here, that one is the minus 3, that one is the 5, that one is the 4, that one is the 6. Okay, and its transpose, that means we are getting -3, 4, 5, 6. Once again, that one means A cross B, its transpose. Okay, now simply B transpose cross A transpose. So B transpose means at first do 1 3 2 0 minus 1 1. So we can write 1 3 2 0 minus 1 1 because we are transposing B at first. Then 1 2 minus 1 1 2 0. That is the case. That is our B transpose. That is our A transpose. Let's multiply it. So 1 cross 1 plus 2 cross minus 1 plus minus 1 into 2. 1 cross 2 plus 2 cross 1 plus minus 1 into 0. 3 cross 1 plus 0 into minus 1 plus 1 into 2 and 3 cross 2 plus 0 into 1 plus 1 into 0. We are getting 1 minus 2 minus 2. That means minus 3. Then 2 plus 2, 4 minus 0. That means 4. 3 plus 2. That means 5. And final 6 plus 0 plus 0. That is 6. So that is B transpose cross A transpose. That one is equal to also A into B whole transpose. Let's check what is happening with A transpose into B transpose. A transpose, that means the order is 3 cross 2. Okay, with B transpose, that means 2 cross 3. Multiplication is possible, but whatever we are getting, A transpose cross B transpose is equal to 3 cross 3 order. Okay, so both are not equal. So always A cross B transpose is equal to B transpose into A transpose, not A transpose into B transpose. So up to that, the operations on the matrices, then the transpose of the matrices and the properties of the matrices. Next one is very important. Another one thing that is called, that is also according to the transpose of the matrix. So those terms are called the symmetric matrix and skew symmetric or skew symmetric. Two types pronunciation occurs. When we have a matrix, suppose A, and that is also equal to its transpose. We have a matrix A and its transpose is also the equal A. Then we must say that matrix A as the symmetric matrix. Symmetric means ki na symmetry is occurring. That's why it is called the symmetric matrix. Suppose we have a matrix like A is equal to 2 minus 1 4 minus 1 7 8 and 4 8 6. Okay, just look at the first one row, 2 minus 1 4. Just look, that one is also our first one column. Second one, suppose another one, second row, minus 1 7 8. That is also our second column. Suppose another one, 4 8 6, our third row. That is also our third column. So if we proceed with A transpose, we are getting 2 minus 1 4. 4, -1, 7, 8, interchanging the row and column, 4, 8, 6. So we are getting the matrix itself. So we must say that A as the symmetric matrix. Just look at this thing here. That one -148 is same as -148. That's why it is a symmetric matrix. Okay. Next one is called the skew symmetric. Now the skew symmetric means A is equal to or A transpose. At first transpose, we are getting the result as -A, not A. In the case of symmetric, A transpose is equal to A. In the case of skew symmetric, A transpose is equal to the -A. Let we have a matrix A like 0, 3, -1, then -3, 0, -4, then 1, 4, 0. Okay, let's check with its transpose at first. Okay, so A transpose is equal to, interchange the row and column. So 0, 3, -1 was the first row. I am writing it 0, 3, -1. First row is now first column. Second row, -3, 0, -4 is now second column. 1, 4, 0, 1, 4, 0 is now third column. Now I am writing it in a different way. 0 means we can write -1 into 0. -3, we can write -3 into 1. 1, we can write -1 into -1. Remember that is +1. That's why we have written it as -1 into -1. 3, so that means we can write it -1 into -3. Okay, 0, so -1, that one is wrong here. Whatever we have to write, -1 into 3, sorry, not -3, -1 into 3. 0, -1 into 0, then -1 into -4, so that's why it is +4. -1 into 1, -1 into 4, and -1 into 0. Okay,
স্যারটা -4 আছে।
কোনটায়? হ্যাঁ, তো -4, that's
ওটা
why
তো
I have
গুণ করলে মাইনাস করবে।
that's why -1 into 4. So we have with each and every element -1 is common. So we can take the common -1 from here, each and every element. Okay, as like that is the scalar multiplication. -1 is multiplied with each and every element of the matrix, then that is the decomposition, that -1 has been taken common from each and every element. So first of all, it is becoming 0, second one 3, third one -1, fourth -3, 0, then -4, then 1, then 4, then 0, then 4, then 0. So what it is becoming? -1 into, look at the thing, that is our A. Just look here, 0, 3, -1, -3, 0, -4, 1, 4, 0. So we can write that is -A. So A transpose is equal to -A. Then we can say that matrix A as the skew symmetric. That means when we have the transpose of the matrix and it is becoming the negative of the self matrix, then we can say the matrix as a skew symmetric.
স্যার বলছি যে এটার ডায়াগোনাল এলিমেন্ট সবসময় কি জিরোই হবে?
Most of the cases. Most
Okay,
of the
sir.
cases. Okay. Another one thing. Achha, any other question from that side? Skew symmetric and skew symmetric?
No, sir.
Okay. Suppose a very important question or important type thing, that representation of any matrix, representation of any matrix as the addition of a symmetric matrix and a skew symmetric matrix. Any matrix can be represented by the addition of a symmetric matrix and the skew symmetric matrix, and that is practically A. Suppose the matrix is equal to, we can say, half of A plus A transpose plus half of A minus A transpose. The first one is a symmetric matrix. The second one is a skew symmetric matrix. Okay, let's check what is happening. I am just decomposing. Half of A plus A transpose. Half of A, that means half A plus half A transpose, plus half A minus half A transpose. That means we are subtracting those. So we are getting half of A plus half of A is equal to A. But that is the representation. That one is the symmetric, that one is the skew symmetric. Let's check with an example. Okay. Suppose any matrix, we don't know what should be it. We are proceeding with a square matrix. A is equal to, suppose, 1, 2, 3, 4, 5, 6. Okay. Then only one thing I have missed, that the symmetric and the skew symmetric matrix are the case of square matrix only. Okay. Only the case of square matrix in the case of transpose. Otherwise, we cannot say for the symmetric or skew symmetric. 1, 2, 3, 4, 5, 6. So that is the A. So at first we are finding the A transpose. Sorry, 4, 5, 6, 7, 8, 9. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. So that was a 3 cross 3. That was a 3 cross 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what is the symmetric matrix at first? Okay. So that is half of A plus A transpose. Okay. So half of A plus A transpose. 1 plus 1, 2. 2 plus 4, 6. 3 plus 7, 10. 4 plus 2, 6. 5 plus 5, 10. 6 plus 8, 14. 7 plus 3, 10. 8 plus 6, 14. 9 plus 9, 18. And you may check already 6, 10, 14. 6, 10, 14. That is already a symmetric matrix. We don't multiply with the half. Otherwise, also that is a symmetric matrix. Okay. If we transpose it, we are also getting the same. That means 2, 6, 10, 6, 10, 14, and 10, 14, 18. That is the same. So the first one is the symmetric. Another one is the skew symmetric. That means half of A minus A transpose. So half of A minus A transpose. Let's check. Half of 1 minus 1, 0, 2 minus 4, minus 2, 3 minus 7, minus 4, 4 minus 2, 2, 5 minus 5, 0, 6 minus 2, minus 2, 6 minus 8, sorry, 7 minus 3, 4, 8 minus 6, minus 2, and sorry, that one is
So এটা শুধু 12?
plus 2, right? Plus 2,
Mm.
plus 2, and 9 minus 9, 0. Okay, you may check what is the similarity. If that is minus 2, that must be plus 2. If that is minus 2, that must be plus 2. If that is minus 4, that must be plus 4. So that is a skew symmetric. We can check. If we transpose it, we are getting that one as the minus A of. So that one is a skew symmetric. So we can write A. That means 1, 2, 3, 4, 5, 6, 7, 8, 9 as addition of a symmetric, that is half of 2, 6, 10, 6, 10, 14, 10 plus 14, sorry, plus 14, 18 plus half of 0, minus 2, minus 4, 2, 0, minus 2, 4, 2, 0. That one is the symmetric, and that one is the skew symmetric. So any matrix, square matrix, can be transformed or can be written or can be expanded in the form of the addition of a symmetric and the skew symmetric matrix.